Astronomers just found something at the edge of our solar system, and it's making the Planet 9 mystery even harder to solve. For years, we thought we knew exactly where to look, but new data changes everything. The orbits of distant objects are far more stable than they should be, which means if Planet 9 exists, it's much further away than we ever imagined. Or it might not be a planet at all. This is a complete game changer for astrophysics. Let's go back to the beginning. In 2016, two astronomers from Caltech made a bold claim. Konstantin Batygin and Mike Brown announced they had evidence of a new planet, a massive world hiding in the darkest reaches of our solar system. They didn't see the planet itself. Instead, they saw its gravitational footprint. Way out past Neptune, there's a ring of icy debris. We call it the Kuiper belt. Most objects here orbit the sun normally. But Batygin and Brown noticed a strange anomaly. A group of extreme trans-Neptunian objects were clustered together. They were all tilted at the exact same angle, and they all pointed in the exact same direction. The chances of this happening randomly? About 1 in 10,000. Something massive had to be pulling them into place. A planet roughly 5 to 10 times the mass of Earth. This hypothetical world was dubbed Planet 9. It was the perfect explanation. For years, astronomers have been scanning the skies, looking for a faint, slow-moving point of light. Because it's so far away, sunlight barely reaches it, making it incredibly dim, and its orbit is vastly elongated. One trip around the sun could take up to 20,000 years. It's like looking for a black needle in a dark room. But the search never stopped. In fact, it only intensified. Just this year, the search took a dramatic turn. 3 major new discoveries were published. First, astronomers using the Subaru telescope in Hawaii spotted an object they nicknamed Ammonite. It's the 4th member of a rare group of sednoids, objects with orbits completely detached from Neptune's influence. Ammonite's discovery is crucial because it adds another piece to the orbital puzzle. Computer simulations using Ammonite's data were run. The results were completely unexpected. If Planet 9 is out there, causing these orbits, its own orbit must be much further away, further than anyone had previously calculated. Then came the second massive discovery. Researchers from Princeton and the Institute for Advanced Study found a dwarf planet called 2017 OF201. They found it right in the middle of their Planet 9 search data. This object is incredibly distant. A single orbit around the sun takes it 25,000 years. It's one of the most extreme objects ever discovered. But the most shocking revelation was the third one. New calculations questioned the core foundation of the theory. Astronomers analyzed the long-term stability of these distant objects. They found their orbits are surprisingly stable on their own, more stable than they would be if Planet 9 was disturbing them. This is a massive contradiction. Planet 9 was proposed to explain these orbits, but its predicted gravity might actually disrupt them too much. Does this mean Planet 9 doesn't exist? Not exactly. It means our models are incomplete. If the planet is there, it must have a different mass, or it's on a completely different orbital path. Perhaps it's much smaller and closer, or much larger and vastly more distant. The mystery hasn't been solved. It has just deepened significantly. We are looking at a puzzle where the pieces keep changing. Every new object we find forces us to rewrite the rules. The edge of our solar system is not a quiet place. It's a dynamic, chaotic frontier, and we are just beginning to map it. Some scientists propose alternative theories. Could it be a primordial black hole? A tiny black hole the size of a grapefruit, captured by our sun. It would have the same gravitational effect, but it would be completely invisible to our telescopes. Or perhaps it's a massive disk of dust and ice, a collective gravity of millions of small objects, acting together like a single giant planet. Both theories have their supporters, but neither is proven. So, how do we finally solve this? How do we see the unseeable? The answer lies in next-generation technology. We are about to turn on the most powerful eyes in history. First up is the Nancy Grace Roman Space Telescope, set to launch in September 2026. Roman will have a field of view 100 times larger than Hubble. It's designed to survey vast swaths of the sky, It will discover tens of thousands of exoplanets, but it will also stare deep into our own solar system. Roman's infrared sensors are incredibly sensitive. They can detect the faint heat signature of a distant icy world. If Planet 9 has any internal heat left, Roman will spot it glowing in the dark. Then there's the Vera Rubin Observatory in Chile. This massive facility is preparing for first light. It features an 8.4-meter mirror and a 3.2 gigapixel camera, the largest digital camera ever constructed. Every few nights, Rubin will image the entire visible sky, creating a continuously updated cosmic movie. It will track the movement of billions of objects, including anything shifting slowly in the outer solar system. Rubin is expected to find thousands of new trans-Neptunian objects. Even if it doesn't photograph Planet 9 directly, the sheer volume of new data will be definitive, with thousands of new orbits to analyze. The gravitational signature will become undeniable. We will know exactly where Planet 9 is hiding, or we will know for sure that it isn't there. There will be nowhere left for it to hide. We are entering the golden age of sky surveys. The next few years will bring answers, and those answers might reshape our understanding of the solar system. Let's look at the numbers. Neptune is 30 times further from the Sun than Earth, but Planet 9 could be 400 to 800 times further. At that immense distance, the Sun looks just like a bright star. It offers almost no heat and virtually no light. Any planet there would be frozen solid, a dark, lonely ice giant wandering through the perpetual night. How did it get there? Some models suggest it formed closer to the Sun, in the early chaotic days of the solar system. Back then, giant planets were migrating. Jupiter and Saturn were shifting their orbits. This gravitational dance was violent. It may have violently ejected Planet 9, throwing it out into the deep freeze of the Oort cloud, where it has lurked ever since. Others think it might be an alien world, a rogue planet captured from another star system. As our Sun passed near another star billions of years ago, it could have stolen this dark world, making it an adopted member of our solar family. Whichever origin is true, finding it changes everything. It would be the first major planet discovered since Neptune in 1846. Pluto was found in 1930, but later reclassified. Planet 9 would be a true major planet, earning a permanent spot in our textbooks, and completely rewriting the history of our solar system. We are standing on the brink of a monumental discovery. Planet 9 represents the great unknown, a ghost world haunting our astronomical models. Whether it's a super-Earth, a primordial black hole, or a complex ring of debris, the anomalies are real. Something is out there, pulling the strings in the dark. The recent discoveries of Ammonite in 2017 OF201 prove that the outer solar system is full of surprises. The fact that the orbits are more stable than expected only adds to the profound mystery. Science is not just about finding answers. It's about asking better questions. And right now, the outer solar system is asking us a massive one. We've mapped the entire visible universe. We've seen galaxies forming at the dawn of time. We've photographed black holes in distant galaxies, but we still don't know what's in our own backyard. The dark edge of our solar system holds secrets, and we are finally building the tools to reveal them. The search continues,